Fundamental problem F12-8 says a particle travels along a straight line with a velocity of v equals 20 minus 0.05 s squared meters per second, where s is in meters. Determine the acceleration of the particle at s equals 15 meters. Alright, so first of all, let's go ahead and quickly try to visualize this particle here. For the starting position of the particle, I'll go ahead and represent it as a red dot, where that is at the position 0 meters, and then to the far right we have the 15 meters. So along the horizontal axis is the position s in meters, and then again on the right we have the particle at 15 meters, which is of course the position we want to determine the acceleration for. And then of course, keep in mind that this particle, as it moves to the right, it has an acceleration and velocity. And now just quickly describing velocity and acceleration in terms of time. V equals ds over dt and a equals dv over dt, which pretty much tells us that velocity is the derivative of position with respect to time, and acceleration is the derivative of velocity with respect to time. And now if we solve for dt in both cases, we will get dt equals ds over v for velocity, and dt equals dv over a for acceleration. And since they are both equal to dt, we can form the relation ds over v is equal to dv over a, just like so. And now rewriting this, we can have the relation ads is equal to v dv. And now this is useful because this equation relates acceleration, position, and velocity, and it allows us to determine the acceleration of the particle at a certain position. And if we were to solve for this acceleration, this tells us that acceleration a is equal to velocity v times dv over ds. And now of course here we know what v is, as we're given the expression for velocity. And so we can also use this expression to find dv, which is essentially the derivative of velocity, and that is of course with respect to position ds. So all we need to do here is differentiate this expression for dv. So taking the derivative of this expression here, the derivative of 20 is of course 0. And for the derivative of 0.05 s squared, we multiply the 2 to the 0.05 and subtract 1 from 2. So that'll leave us with negative 0.1 times s to the power of 1. So now that we have differentiated velocity, we can go ahead and solve for the acceleration by substituting in the value of s. So acceleration a is equal to 20 minus 0.05 times s, which is 15 meters squared, and then times the derivative dv by ds, which is negative 0.1 times 15. So simplifying this out, we get a equals negative 13.125 meters per second squared, which we can also write it by its magnitude, where a is equal to 13.125 meters per second squared.